Hey everybody, this is Larry. This is me trying to do the third weekly premium problem. Is that the right phrasing? Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this problem. It's week 3 on the January weekly challenge. Ooh. Okay, so today's problem is 1533. Find the index of the larger number. It's a premium problem, one that I haven't solved yet, so I'm excited to kind of see a new one. Okay, so you have an integer array R where all the integers in R are equal except for one integer which is larger than the rest of the integers. Okay, oh no. You're not given the direct access to the array. Instead, you have an API array reader which have the following function. What? Okay, let's okay. I mean, it's gonna be binary search probably, but let's see what they're trying to do. Okay, so you want to compare sub, which is maybe a sub array of left, right, x, y, because okay, so basically it's L1, L2 really, and then R1, R2, and then basically if the left subarray is equal to the right subarray, right? Okay, I mean I think this is pretty. And you return the index. Yeah, I mean it is going to be binary search, right? Basically you and in this problem you know that it's larger, which helps, but basically you want to get, so one is if the left side is bigger than that's kind of not the right notation, I think, but okay, fine. I think that's, I'm almost certain that it's the other way. Yeah, because it's right minus left, right? Okay, anyway, it doesn't matter. As long as we're consistent, it's fine. Okay, so I guess we need to get n is equal to reader.length, right? And then this is just binary search. The only thing that is a little bit tricky is that obviously you have to make sure that the index is divided by 2, which is not that, I mean, so like there's a little bit more trickiness, but it's not that bad, I think, because we'll get into it when we get there then. But left is equal to 0, right is equal to n minus 1, right? So then now, while left mid is equal to left plus right over 2, this is regular binary search stuff. Let me just create some space so I could kind of scroll this up a little bit. Wish they just let me do that without creating space, but okay. So then now we just have to make sure that okay, so then now we want to go from left to mid minus 1, mid to right minus right inclusive, right? Okay, right? Yeah, and you could do some maths as well, but so the difference between or the number, I'm always really bad at this, so give me an extra second to kind of think about it. Because basically if there's one number, then right and mid will be the same. So right minus mid plus 1 is the number of numbers in the middle, or 1. So okay, so let's just say and right and left is equal to mid minus 1 minus left plus 1, something like this, right? Let me think about this for a second. I'm thinking whether this can be, I think this, can this be, like, can n of left be negative? I think that's where there are a lot of like weird issues with. Is it better to do mid and mid plus 1? I guess this has the same issue. No, I guess it doesn't, because mid can never be right, maybe. Because if mid is right, it means that left is equal to right, so they would never execute. Okay, I think this is a little bit better. Okay, I'm convinced maybe. I don't know, we'll see if that actually is true. minus, so it's technically this and this, but then, you know, that should be fine. And I know that they get canceled out, but I'm just, okay. So if n left is equal to n right, then we can just do a naive comparison. I mean, I know that you can probably write it in a more one line kind of way, but I'm just, you're seeing my thought process, and I'm just going to do it. I'm going to focus on getting it correct, and then maybe after we get it correct, then we can focus on optimizing, making the code a little bit cleaner after that, because then now we have a base to build off, right? No point of optimizing bad code, either clean or in terms of code cleanness or whatever, right? So okay, so if they're both the same, then we can just directly compare them, which means if compare sub, is it reader.compare subarray of what do we say? We want to go from left. Is it inclusive? It is inclusive. So yeah, we want to go left to mid plus 1, right. So if this, let's just get the result, because apparently, because it could be 3 things. If r is, well, actually it doesn't, right? Because it cannot be equal to 0 because it has the same elements, I think. Maybe I should, or is it not equal to 0? If this is equal to 1, then the answer is on the left side. So that means that we want to make the right is equal to mid, because mid is a possible answer, right? Else, mid is not a possible answer because the right component or the right half is going to have it. So left is equal to mid plus 1. Okay, so I think this is good, right? This would be mostly be the answer now. It's not yet, hang on, but yeah. And then else, well, else we have odd number, right? And I don't know that, I have to take a look to see which one. I think the left side would have the bigger number. Am I right? I mean, we could just play around with numbers, right? So if we have, let's say left is equal to 0, right is equal to 9. Well, no, that's 10 numbers, because I'm bad at math. Let's say right is equal to 8, mid is equal to 4. So then now we go from 0 to 4 inclusive, and then 5 to 8 inclusive as well. And of course, there are 5 numbers on the left and 4 numbers to the right. And just to be clear, even though I'm like kind of in theory just like scribbling, this is not real code, or not real intended code. Let me put in comments, but that's my actual thought process, right? Like, this is what I'm thinking. So because everyone is good at different things. For me, I'm like really bad at off by ones, especially recently. Sometimes I'm good, but it hasn't been the case recently. But knowing that about myself, I wanted to kind of force myself to visualize, spend some time and not get a wrong answer, because that costs like 5 minutes on the contest. Just kind of see what it is, and then now that I have the real numbers ahead of me, I can be like, oh, okay, yeah, left is the bigger one. Then I don't have to waste time messing around with it. Okay, so in this case, what we want is actually, because one side is bigger than the other, let's just do left plus 1 mid plus 1 right. So we skipped left, or index of left, if you want to be precise, right? So then now, if r is equal to 1, what does that mean? That means that the answer is within this range, and that actually there's a thing that we can. I mean, we often think about binary search as just like this thing where we just move left, right, and I think that's the thing where, if you don't have a good understanding of binary search, maybe you can kind of hack this in a way such that the generic binary search makes sense as well. But having a good understanding of binary search allows you to kind of write things in a way that I'm doing, so that you can be as precise as possible, as long as you have the time to do it. Because I think during contest mode, I get a little bit, I don't know, I get a little bit tilted or whatever, and I just kind of rush things. Also something I know about myself and try to be a little bit better about, but so that's what I'm telling you, I guess. But yeah, but now we know that it is. So now the answer is between left plus 1 mid, right? So what does that mean? Why do I write it out? Well, I write it out because this is in contrast to here. Because here is actually between left to mid. So what does that mean? That means that we know that reader sub left cannot be the answer, right? So what that means is that we can actually increment this by 1 as well, and right is equal to mid, because now the range that we're sorting is left plus 1 to mid. And we set that by setting left. I mean, you could also set left is equal to left plus 1 if you want to be. Maybe this is like a little bit more specific. I know the increment does the same thing, not whatever. But this allows us to kind of be really, really precise about it, right? Okay. And then now if r is equal to 0, then we know that left is the answer because that's the number that we skipped. And then now we know that r is equal to right, then answer is between mid plus 1 right. So this one is actually the same as this one. So we just said left is equal to mid plus 1. So this one, there's no weird thing about it. And yeah, like I said, this may look a little bit funky, and you could probably optimize it, but that's the way that I would think about it. And again, yeah, we return left and middle. I missed something that I usually say about binary search, which is that in the beginning, we want to search between left and right inclusive, right? And what that means, and why do I set it up this way, is that because now when left is equal to right, our interval is our search interval is 1 element, so that must be the answer. That's the way that I like it. I know that sometimes people do like the plus 1 thing or the thing, I don't know, but this is the way that I think about it, and that's why I can return left. You could also return right because they should be the same number. This looks good for the thing. Is there really I mean, this is our number, but I don't know if there's like a bad case that I really go over. So I don't know. I mean, I think the right way to test this is just look at this, and then I mean, it's not the right way, the only right way, but just move it along every, basically check every position for some odd number away. This is 8 elements, so maybe that's even kind of not so good, but yeah. And of course, I do worry about whatever, but yeah, cool. I mean, yeah, still 10-20 day streak, binary search, and that's pretty much it. Let me scroll down to you could kind of see all the code, but not really. Let me okay, with the comments anyway. Okay, let me just make it slightly smaller. Okay, now you can see all the code. Yeah, so what is the complexity here? I mean, this is binary search, so yeah, given an array of n elements, we are going to this is going to do O of n operations, or sorry, O of log n operations, and I didn't even look at the size of the array, but 5 times 10 to the 5th, which means that it is less than 1,000,000, which for 1,000,000 it's going to 2 to the 20, right? So it's about like 19 or something like this operations at max. But log n is the answer, where n is the size of the array. That of course assumes that this is O of 1 or whatever, but you could say log n times the cost of the comparison operation, which is something that you use as an API. So you could say maybe it's O of 1 with a prefix sum or something like this, but technically you don't know, right? So whatever. Yeah, and I don't use any extra space other than some constant things. So yeah, that's pretty much it. That's all I have for this one. I do wonder if, I mean, maybe you could kind of clean this up a little bit, but like you could probably combine them in a way, but I think this is actually very into, like very detailed case by case analysis. So I think that's, I don't know, I prefer it. Anyway, that's all I have for this one. It is more readable if you ask me to be, there is some like code to dedupe that maybe you could do, but I think this is more readable because it's more understandable, right? Versus things that are like, okay, maybe it's 5 lines, but then if you don't understand it, you don't understand it. So yeah, That's but yeah, that's all I have for this one. Let me know what you think. Stay good, stay healthy to good mental health. I'll see y'all later and take care. Bye bye.